Assuming that there are no heat effects and no frictional effects, find the kinetic energy and speed of a 3,200 pounds body after it falls to 728 feet from rest. Start with the steady flow equation, deleting energy terms which are irrelevant. So we have here a given, so let's put the given first. So we have the given of height, which is 778 feet, and a mass of 3,220 pounds. After which, we have to put the required, which is the kinetic energy and the speed. So we have the formula of, so as what in the problem stated that excuse me, please bear with my voice because I'm not feeling well. So it stated that from rest it falls down to 778. So basically it's PE to key from potential energy to kinetic energy. So as we all know, P is equals to mass times gravitational height to K, which is constant, is for KE is mass times mv squared times 2K, which divided by 2K, which is the constant. So let's for the V is 2 times gravitational height, and for the KE is V square root of 2 gravitational square root of 2 gravitational height. So that will be the formula that we will be using later. I'm sorry, so this is 778 actually. So to find V, I have here written down V is equals to square root of 2 GH. So I have here a 2 multiplied by the gravitational force, which is 32.174 times, as we all know, mass is equals to 3,200 pounds. So yeah, as you can see in the video, the height, which is 778. So 2 multiplied by 32.174 multiplied again by the 778. So now let's tabulate in the cycle to get the answer. So we have 223.74. Okay, let me have a moment to reflect if I get it right or not. So basically I got it right, so let's round up. So it will be 224 feet per second. So for number 2, a reciprocating compressor draws in 500 cubic feet per minute of air whose density is 0.079 pounds cubic feet and discharges it with a density of 0.304 pounds cubic feet. At section, PO at absolute pressure, which is 15, at discharge of P2, which is absolute pressure of 80, The increase in the specific internal energy is 33.8 British thermal unit pounds, and the heat transfer from the air by cooling is 13 British thermal unit pounds. Determine the work on the air in British thermal unit minute in HP. Neglect change in kinetic energy. So we have here the given here, of course, the V, the P1, the density, the change of thermal energy. So as you can see, the formula will be like P multiplied by V. So let's substitute the variable. So the P is 0.079 pounds multiplied by 500 feet cubic. Then the answer would be that. Then the next one is workflow. So P1, V1. So I got the 1.44 British thermal unit. So that will be the tabulation, 35.14. So let's move on to the workflow 2, which is P2, V2. Then all you have to do is substitute, then tabulate, then I got the answer. So yeah, then cancel the unit so that you can get your answer. Then let's proceed to the workflow 1, which is there is a formula there, and all you have to do is substitute all the variables and the values. So that's why I get the 60.364, because all I have to do is it multiplied by 39.51 pounds. So now I got the negative 238 point something. So yeah, as you have seen in the video, I'm trying to get the answer. So I got the 2384.378. British thermal unit. So as for my final answer, I have to tabulate again to get the 56.25 HP. So all I have to do is negative 2.3084.78 divided by 42 point something. So I'm trying to get the answers because I'm really confused if I get it right or not. So actually there's a formula there, and all I have to do is analyze and substitute all the answers. So that would be for my final answer. So as you can see, I've been trying like many times because I'm really confused either if I get it right or not. But I won't give up, not until I get the final and correct answer. So yeah, so there you are. I got negative 56.23 something. So that will be my final answer. So this is my given in number 3 problem. So I had like the H1, the H2, the heat, the mass. So required as work in British thermal unit and HP. So E in and E out, whatever the variable that you have input would also the same variable that will come out in out. So as you can see in the video, I concealed all the units so that I get the answer, which is 512.3 HP. So for number 3, I'm gonna read the problem. Steam enters the turbine with an enthalpy of 1